what happens is we get industrial and domestic sewage. They come up these pipelines here raw. So it's both the solids and the liquids. That's how we distinguish between the two. And we start taking it into the system. This is called the headworks. And what's coming into the plant is called influent. So I'm gonna use a little bit of jargon today. If it doesn't make sense, you guys need to speak up, okay? So what comes into the plant? And what's this called? Headworks, very good. So we'll go around to the other side now. So this is where the first process starts. We brought in that 7 million gallons per day, 5 million gallons per day, and we start separating the liquids and solids. And that starts with those two metal tanks up there that are called bar screens. So for frame of reference, our plant, we don't add any chemicals necessarily to treat the water. It's a biological process. So all the microorganisms here do the work for us. So can microorganisms eat solids? Large particulates, chunks particularly? Probably not. So that's what you see these dumpsters over here. We have a corkscrew. And so we remove those solids out and water comes down through this flume and we monitor the pH. Does everyone know what pH is? What is it?
Modified uranium ions.
Very good. So for this plant, we need to be between 6 and 9. If we go below a 6 or above a 9, alarms will go off in the plant and we'll have to shut down the system. So at this point after the headworks, we start going into the primary with the water. But the solids start sinking to the bottom. So as the solids sink, we actually scrape them off and send them to our thickeners over there. So you can imagine when we take solids and we start thickening them, what are we doing? Concentrating them. We're concentrating the solids. That's the only place that we do add some chemicals. We add some ferric chloride. It's a polymer, it kind of binds together. So that's where the first part of our solids go. Okay? Does everyone understand what I mean when I say solids and liquids? We're all, okay, good. Perfect. Just checking. So any questions about going to the thickener buildings? Okay. So we'll come back to the primaries after we do our solid sides of the plant, okay? Because then we're gonna, yeah.
Can you use methane for energy?
Such a good question. We'll get there in just a moment, and we do use methane. So this is a net zero plant. We don't use any energy off the grid. We actually sell energy back. And you see that we have all these solar panels in front, and we have solar panels on all our buildings on the other side. So that's what powers that side of the plant. And then the methane powers this side of the plant. So it's pretty awesome. It feels good to be making a difference in the environment. So after the thickened sludge gets thickened, we need to give it time to do what the microorganisms do best, because even in the sludge, we still have bacteria and microorganisms working. So they get sent to these holding tanks, and we hold them for a certain amount of time. The operators decide that that's an operational side. They check it every 2 hours to see what's happening in the plant. From the holding tanks, we then feed our digesters. A digester is like a big stomach. So what's happening in these digesters is the same thing that happens into our digestive tract. It's a little bit acidic, but we have carbon dioxide in there and we have methane creation. And I believe their nitrosomonas is the bacteria in there. So that's what's creating all of it. So we have a lead digester and a lag digester. The lead digester is actually what we send to our belt press to create those lovely piles of biosolids. What creates some of our methane though is we also accept grease loads here. So that's fast food grease. It's basically anything where you go out to eat. We'll accept that here. That's on the other side of these digesters. So what we're gonna do is kind of swing around and check out our grease station. We'll see our methane sphere, and then we'll see our biosolids. So any questions about the digesters? Yes?
What do you not accept at these places?
So right now we accept small loads of food waste. So is everyone familiar with East Bay mud? Okay, so East Bay mud takes everything, right? So they're using a lot of food waste now to create some of their energy needs. And that's one of the things that we're just starting to take. When you add food waste to your digester though, there's a little bit different chemistry going on. So we have to be really careful that we don't upset our stomach, basically. And so that does happen occasionally where you upset your stomach and they have to add lye to it. So we want to be really careful to keep a nice balance. So good question. So we'll head around the back now to see our grease receiving station. So now we're on the back side of our digesters, and you can see behind you, if you're brave, this is our grease receiving station. This is what happens when you have a lot of grease coming in. That's why it has its own spot. This is the holding tank for the grease. So we have to make sure that before we feed it into the digester that all the chemistry is right. So digester 1, digester 2. Digester 1 now goes into this building. So this building is split. We have our belt press, and this is the cogeneration facility. Someone asked about methane. There's our sphere. So any methane that's produced, any overage goes into the sphere. So we check our methane content because the Monterey Air Pollution Control Board regulates us. So we have to send in those amounts. So we keep our digesters about 32% methane in carbon dioxide. So it's kind of what we don't want to release any into the atmosphere, right? So any questions here? Okay, we'll head over to the biosolids. So our biosolids have to be treated to a certain level as well. Like most soil amendments, it has a certain class. We were a Class A sludge, now we're a Class B. And that's based on a lot of different parameters. One of the parameters is a bacteriological count, which we do every other month at 7 discrete locations. So you can see it's kind of bare. That's not because Watsonville doesn't use the bathroom. We had a lot of our solids just hauled away into the Central Valley. They came and they took truckloads of it. And so we use our biosolids. What happens after it comes out of the digester is it has some liquid content still, right? So what we need to do then, if we're gonna turn it into this dry soil amendment, is squeeze the water out. What else can we add to squeeze water out? I said it earlier in the thickener buildings. Polymer? So we bind the water to that too, and we start squeezing it. It comes out on this belt press, which you see here, dropping it into a pile, and then they spread it out to dry. What would spreading it out on these fields do? Evaporate any water, which would then in turn do what to a bacteriological count?
Oh, bacterial.
Yeah, so if you're it'll decrease, right? Because you're using solar power to then decrease the amount of water or any nutrients that the bacteria could use. So we're basically trying to kill any bacteria in there. We have certain limits before they'll haul it away that we have to meet. If we don't meet it, they won't take our sludge. We actually pay them to take our sludge. So we've got to make sure that we have a good, and we monitor metals and nutrients. So yeah, City of Santa Cruz is a good example of, they don't have these, we call them drying beds. They don't have the beds like this. I don't even think East Bay Mud really does either. We're one of the few places locally. Gilroy is one of the plants where they have the truck sitting under their belt press, just waiting to drive away. So their operators, and 2 women who are operators in training here now work over there. They have to have their, what is Class A? Is that the big truck driving license? They have to get their Class A license to work over there. So yes, Watsonville is very fortunate. We have space and we have a good relationship with a lot of the agricultural owners around us. You'll see that there's a lot of corn being grown between the plant and roads, and that's because of the leafy green law that got passed. Is everyone familiar with that? So basically when there was that outbreak of E. coli in spinach, the law requires agricultural to plant a barrier between anything coming into their field. So they reduce the chances of any dirt, dust, animal getting in. So you'll see we have a lot of corn around us right now. That's because we're around strawberry fields.